Okay, I'm going to do a little bit of practice problems for 2.2, and then I'm going to go on to a little bit of 2.3 where we're talking about composition of functions as opposed to algebra of functions. The big key to remember when you're talking about algebra of functions is that these do not act as input for one another. So you wouldn't have an f of g of x, you would have f of x plus an f of, or a g of x, or you would have some other thing where you've actually got two items working together or three items working together, as opposed to having to deal with finding an output from an input and then using that as a new input. So that's really the big key difference between algebra of functions and composition of functions. But let's go ahead and do some practice problems. I am going to say we're going to have our f of x times our g of x, and these are both our formulas, right? We've been told that we can do f of x times g of x. That is the same thing as this. This is exactly the same statement as this. So I'm going to go ahead and I'm going to use my f of x, which is going to be a 2x plus 1, and we're going to multiply that by the 5x minus 3. So 5x minus 3, and we're going to go ahead and just do our distributive property on this. I'm going to just walk through the process. I can also show you how to do it with a square, but we'll go with it for right now. So I've got a 2x plus a 5x, that's going to give me a 10x squared, and a 2x minus a 3x, that's going to get me a minus 6x. Here I have a 1 times a 5x, so I'm going to have a positive 5x here. And I'm going to have a 1 times a negative 3, so I'm going to have a negative 3 here. So these two pieces I can combine, right? I have like terms here. So at the end of the problem, I'm going to have 10x squared minus x, right? Because I have my negative 6x plus a 5x. So my negative 1x or negative x, and then negative 3. All right, and I mentioned I was going to show you the square method. I do a lot of things with squares, if you've not noticed, but it actually winds up being pretty straightforward. And you can do this with as many terms as you need in each of these. So if you had something that was 4 terms long and multiplied by 3 terms, you could actually go ahead and do that, and you take it just one step at a time. So here I'm going to have my 2x. Here I'm going to have a plus 1. Here I'm going to have a 5x. And here I'm going to have a negative 3. So if we take a look, when I multiply my 2x times my 5x, I'm going to get the 10x squared plus the 5x minus the 6x, and then minus the 3. And then these two, of course, we would combine because they are like terms. All right, so let me go ahead and work on the next problem. I want to make sure that we're getting some of these practices in. I want to be sure that it's making sense. So here for my f of x, or f and x, or f of x, and then I have a g of x, and then I have I'm saying that my f is going to be positive, and then I'm going to subtract the g from it. Okay, so if you stop and think about that, that's just going to be f of x minus the g of x. That's exactly the same statement as this. I'm going to go ahead and say I have a negative 3x squared, and I'm going to subtract 3x squared plus 8. So here I'm going to go ahead and distribute this negative all the way through. So I'm going to have my negative 3x, that's the first one, negative 3x squared. So that's this one right here. And now I'm going to have another negative 3x squared minus, right, because my negative multiplies through to both of these, minus 8. So I'm going to wind up with negative 6x squared minus 8. In this case, I'm told that my x is equal to 2. All right. So I have a negative 6 times 2 squared minus 8. So here I'm going to do this exponent. So I have a negative 6 times 4 minus 8. Negative 24, right, these two multiplied together, minus 8 is going to give me negative 32. Now, that's one way of approaching it. This way, I kind of worked my whole process until I got to, I've summarized what my problem is in generic terms, and then I plugged in my specific, right? Now here I'm told that my x is a 2, so that's where I put this in. All right, so I could also go the other way around. I could take this, I could say my negative 3, and then I'm going to have my 2 squared minus 3 2 squared plus 8, so that quantity, all right. So here I'm going to have negative 3 times 4 minus, I'm going to have my 3 times 4 plus 8. Here I'm going to have a negative 12 minus 12 minus 8, right? Because this negative distributes to both of these. So I wind up with a negative 24 plus a negative 8. That's going to get me my negative 32. So either way will get you there. The way people work, they tend to either be really, really abstract, which tends to be this case, right, where you're dealing with this abstraction of an x, where here you have a very specific, and it's absolutely not abstract. So people tend to go one way or the other. There's very little middle ground. So here you would have the abstraction, here you have the very specific, and both of you will get you to the same answer. All right, so here I'm being asked to multiply these two together. Here I have an h, so that's going to become an x to the third times my x minus 4. Well, my x to the third times an x is going to get me x to the fourth, and then my x to the third times a negative 4 is going to get me a negative 4 x to the third. And that's as far as I can go. I'm not given any other information about the value instead of the variable. So that's as good as we get. All right, here I'm going to go ahead and add these two. So my first one, I'm going to have my 5x plus 6, right? And then I'm going to add this 3x squared minus 4x plus 8. All right, that's my g of x. Now I'm going to go ahead and start collecting like terms. Again, ultimately, I'm putting these parentheses on just so that it's really clear which one I'm dealing with. They're not really, I'm not trying to do anything special with them. As soon as I have this spelled out, I actually can go ahead and remove them. And I'm going to go ahead and do my commutative property here. So I'm going to have a 3x squared plus 5x minus 4x plus 6 plus 8. All right, so I've got my 3x x squared. That's the only thing I can combine. Then I have a plus x squared because I have a 5x minus 4x. That's going to give me a positive 1. And then I have my 6 plus 8 is going to get me a 14. And that is as far as we can go. Again, we're not given a specific value, so we have to go with what there is. All right, I am actually going to end this video and start this fresh with this new one since we've got a bunch of fractions involved.